Okay, thank you very much guys for joining in. Now we can start with the lesson. Okay, so now on today's lesson, let's quickly, I want us to also record the lesson. Okay. Can you please confirm if you can see my screen? I'm just waiting for your comments. The YouTube team, I'm waiting for your comments. If you can see my screen, then I can start with the lesson. I can see it. Okay, thank you very much. I was just waiting for one confirmation. So now we can start with the lesson. Let's see what we're going to work on today. Okay, so now remember we said on this session we're going to focus with functions, right? So we're going to discuss functions. Okay, so now let's say that I'm given, let's say we have the equation that is f at x, it's equals to minus into x minus 2, and this is squared plus 1. That is f at x. And now let's say I'm given g at x, which is equals to minus 4. So first thing first, let's draw the graph on the same set of, start by drawing the graphs. Then we're going to answer the questions based on these two guys. So now first thing first, let's start with this given one. Let's start with the y, it's equals to negative into x minus 2 squared plus 1. Let's draw the graph of this function. Okay, so remember to graph, this is in which form? If you check carefully, this equation here, it's given in the form of y, it's equals to a into x minus p squared plus q. Right, it is in that form. First thing first, you can just give me the turning point of this graph because it's easy for us to find the turning point. So my TP, the turning point, remember to find the x coordinate. How do we find the x coordinate of this graph? How do we find the x coordinate of the turning point? We need to take whatever that we have inside the bracket, which is x minus 2 equated to 0. So this will be x minus 2. We need to equate this to 0 and solve for x. So the positive 2. So this is the x coordinate of the turning point. So this will be 2 is 2. Therefore, remember, your TP, the turning point, TP is in the form of P is to Q. So now we have the value of P, which is 2. We need to substitute Q with the sign. So this will be positive. This is my turning point. So when you have the turning point, now you can start finding the x and y intercept. I hope this makes sense. So now we need to find the y intercept of this graph. So we're going to start with the y intercept. How do we find the y intercept? We find this if the value of x is equal to 0, meaning that on the graph where there's, if you're still with me on YouTube, because I see that it looks like we have some issues. Can you guys please confirm if you are still with me? The YouTube team, I can see, is this being recorded? Yes, the lesson is being recorded. Okay, are you guys still with me? Okay. On YouTube, can you please guys confirm if you're still with me? Okay, Ntombizota, thank you very much. So let's go back to the question now. So when you punch this, we're going to get that y is equals to, you can just put everything on the calculator. It's like saying minus inside the bracket, we have minus 2 squared, which will be positive 4. Then the positive 4 will be minus 4 plus 3, which will give us plus 1, which will give us negative 3. So the y intermediate of the y, we already have x as 0, and we just calculated y to be negative 3. So this is my y-intercept. So now that I have the y-intercept, I need to find the x-intercept. And how do we find that? By equating y to be 0. So meaning that in this equation, from the equation y, it's equal to negative into x minus 2 squared plus 1, where this y we put 0, so this will be minus into x minus 2 squared plus 1. Then when we have it like this, we just have to solve for x. The first thing that I advise you guys to do is to expand the brackets first. So way too, thank you for the follow. We'll make sure that you feel at home. Thank you very much for joining the family. So this will be minus, let's expand the bracket, x minus 2 into x minus 2 plus 1. So now I need to multiply out the bracket, but what I need us to note in this problem is that the negative will multiply everything that we're going to get when we do the FOIL method. So the negative will multiply everything that we're going to do when we're going to get when we do the FOIL method. So 0, it's equals to negative big brackets. What is x times x? Is just x squared. Then x times minus 2, x times minus 2, this gives us negative 2x. Negative 2 times negative 2, that's positive 1. That's positive 4. Close the bracket, we still have the plus 1 on the other side. Then this will be 0, it's equals to, let's multiply out the bracket with negative. This will be negative x squared positive 2x minus 4 plus 1. Okay, so when it's like this, we can just add the like terms and say this is 0, it's equal to minus x squared plus 2x minus 4 plus 1 is negative 3. So now remember, before we do anything, before we factorize, we need to make sure that the value of a is positive. So we need to divide everything by negative 1. So this will be x squared minus 2x. No, I think we made a mistake somewhere. So now look at this. This, when we add the like terms here, we get 4x. So I'm just gonna fix that mistake very fast now. So let's fix that. But now let me check on your comments if you guys managed to see the mistake. Okay, no one saw the mistake. Okay, it's fine. Please guys, make sure that you do your FOIL method correctly now, because this is minus 2x minus 2x, which will give us minus 4x. So this will be minus 4x, and then this will be minus 4x, and this will be positive 4x. Let's see. I'm very sorry about that. This will be minus 4x. What's going on here? So we have this as, I just want, okay, so this will be my x, this will be my, so this will be my x, this will be my x, and the factors of 3 that when we add or subtract, they give us the middle term of 4 is just 3 and 1. So since it's positive, both of them should be negative. So this tells us that the x coordinate is x is equal to 3, or x is equal to positive 1. Right, let me check if we have any questions on this problem. Say it's positive 4x. Yes, I saw that we did the error then. I saw that we did the error. So now guys, okay, I'm very sorry guys, the network is not doing good today, but let's continue. Let's hope that the network will improve as we continue with our lesson. Okay, so now when I check, what will be the x-intercept is 3 and 0 or 1 and 0. So these are my x-intercepts. So this will be my x-intercept. So now, if this is my x-intercept, let's quickly draw this graph. I think we have everything that we need to draw this graph. So let's put this graph on the Cartesian plane. Okay, so now we set the y-intercept. It cuts at 0 is to minus 3, which is somewhere here. I'm just going to put my point there and say this is my 0 and negative 3, and then I have the x-intercept at 3 and 0. I'm just gonna put the 3 and 0 somewhere here. We have 1 and 0 there, and then 3 and 0 there. Okay, let's name everything down and say this is my 3 and 0, and this is my 1 and 0. So now we set the turning point. Look at this. We set the turning point is 2 is to 1. We know that this is 1 and 0, this is 3 and 0. You see, we are making a lot of mistakes today. Let's redraw these points. So this will be 1 and 0, this will be 3 and 0. So the turning point we say is 2 and 1. So we're going to put our turning point here. But now look at this. How is the value of A? It's negative. Your graph will be concave down. So the graph will look like this. The graph is concave down. So since the graph is concave down, this is your graph. We only need to plot this g at x. We only need to plot the graph of g at x. Now they said g at x is minus 4. It's like saying y is equal to negative 4. That's the graph of g at x. Let's quickly put that and see what we have. So if this is minus 3, minus 4, it's somewhere there, then we can put the graph of g at x. So this is my g at x, it's equal to minus 4. I hope everyone is happy on how we calculated the graph. So now let's answer the following questions based on what we have, based on these two graphs. The first question says, for which values of x values of x will f at x be equals to g at x. Where is this two graph equal? So it's like they are asking you to find the point of intersection. So to find the point of intersection, you just have to equate the two graphs, okay? So what's your f at x? We know that f at x, please, f at x is minus into x minus 2 plus. Okay, so let's write f at x down. This is minus x minus 2 squared plus 1. We need to equate this to g at x, which is just minus 4. Okay, let me check if we have any questions. Okay, great. Everything is good so far, right? So now we equate these two graphs. Then what happened next? We solve for x. Let us quickly solve for x. So to solve for x, remember we said I'm just gonna skip the please allow me to, okay, it's fine. They will expect you to show all the steps in an exam net. So this will be minus into x minus 2 into x minus 2 plus 1. It's equals to 4. We expanded the bracket. Then remember the negative is multiplying everything inside those brackets. So now we got this to be x squared minus 4x plus 4. Then this is plus 1, which is equated to minus 4. This is minus 4. Okay, so we multiply out the bracket with the negative. We have minus x squared plus 4x minus 4 plus 1 is equal to minus 4. So let's add the like terms this side. So this is minus x squared plus 4x minus 4 plus 1. What is minus 4 plus 1 equals to? Is just negative 3. The 4 comes this side to be positive 4, and this is equated to 0. So when we continue working on this, what do we have? We have this as negative x squared plus 4x minus 3 plus 4 is positive 1, and we equate this to 0. So now we need to divide everything by negative so that we can have this as x squared minus 4x minus 1, and this is equal to 0. But now, when we factorize this, I think everyone can see that there's no way we can find the factors of this. So the best way to do this is to find, is to use the quadratic formula. This is minus b plus or minus the root of b squared minus 4ac, and everything is divided by 2a. Right, so now this is x, it's equals to this equation there. It's in the form of ax squared plus bx plus c. Right, so guys, please tell me what is the value of a, what is the value of c? The YouTube team, what is the value of a, what is the value of b, and what is the value of c? Come on, the YouTube team. Because when I look at this one, remember it is in the quadratic form. The value of a is just 1. So I know that a is 1. I'm just going to write down this one and say a is 1. And the value of b is the coefficient of x, which is minus 4. And the value of c is your constant value, which is minus 1. Make sure that when you do your substitution, you substitute all the values correctly. So this will be minus inside the bracket. What is b? b is just minus 4 plus or minus the root of b, which is minus 4 squared minus 4 into the value of a. We said a is 1 and the value of c is minus 1. then everything is divided by 2 into 1. Right, the YouTube team, are you guys still with me? Do you guys understand how we did this one? The substitution, are you guys happy with the substitution? I don't see your comments, guys. Is everybody happy with the substitution? Warona, thank you for sharing the live. Umo, thank you for the follow. Thank you for joining the family. We'll make sure that you feel at home. Okay, please try to punch this on the calculator. They are equal at x it's 4.2 and also at x it's equals to negative 0.2. Okay, so now let's say we need to answer the following question. Where is f at x? Where is the graph of f at x greater than? Where is the graph of f at x greater than g at x? Where is the graph of f at x greater than g at x? So now they are asking where is f at x above g at x. Where does f at x lie about g at x? Let's go back to our graph. Where is f at x above? I'm just going to highlight the part where f at x is above. You see from this point, going that direction, this is my f at x. And we can see that f at x is above g at x between those point of intersection going in that direction. And already we know what is our point of intersection. The one that is negative, this one, since this point here, it's in quadrant 2. Maybe we should just annotate this now. This point is in quadrant 3. All the x values are negative this side. So this tells you that we check the point of intersection. Which one? This one is the one that is negative. So we can see that this point of intersection is negative 0.2. This is the point of intersection. So it's at negative 0.2. So another point of intersection is this one here, which is positive. We need to refer to this other side. It's just 4.2. So I'm just going to put this and say this is my 4.2. So now when they ask where is the f at x above g at x, is from this point going that direction and from this point going that direction. So x must be less than 4.2 and greater than negative 0.2. So the solution here is that x must be less than 4.2 and greater than negative 0.2. I'm not sure if you guys are still with me. Onalena, I see. And Tombi Zotwa is saying a is equals to 1, b is equals to... Yes, thank you very much. That's very correct, guys. That's very correct. Onalena, Papa, Tombi Zotwa, I see you got 4.24. Yeah, so I just rounded mine to 1 decimal place. It's fine. And then we have Tandeka also got the correct answer. Thank you very much. This is 0.2. I rounded my answers, guys, to 1 decimal place. I don't know why, but it's fine. If you round off yours to 2 decimal places, remember, you need to follow the instructions from the question paper. Right, now, let's answer this one. Let's try to analyze on the graph. Where is the graph of f at x? Where is f at x? Where is f at x less than or equals to g at x? Where is f at x less than or equals to g at x? So we need to check where is f at x below g at x. So now it's below from this point here going down, and from that point there going down. So this tells you that from this point going in that direction, it's f at x is below g at x, and from this point going in that direction, f at x is below the g at x. So x must be less than minus 0.2. X must be less than minus 0.2. Let's write it down. X must be less than or equals to negative 0.2, or the value of x must be greater or equals to that 4.2. And that's it. That's it. This is how you answer the exam questions. I'm just gonna pause here and see if we have any questions on this one. Do you guys have any question based on what we've covered so far? I'm waiting for your comments. Do you guys have any questions? No question. Okay, Onalinda. Okay, let's work on another type of question that you can get in an exam. Let's try this one. Okay, so let's say we have g at x, it's equals to 2x squared minus 2x minus 12, and we also have f at x, which is equals to 2x minus 6. So we have a quadratic function and what? We have a quadratic function and a linear function. Okay, so now we're not going to draw the graph yet. Let's start by answering the following questions. Let's say this is what you have. You are given the two graphs, and let's start by answering the following question. Number one, for which values of x is f at x? For which values of x is f at x equals to g at x? So when they ask you about f at x is equals to g at x, they just need you to find the point of intersection where these two graphs meet. So you just have to take, not f at x, we are working with, okay, yes, f at x is equal to g at x. So now what is your f at x? My f at x is 2x minus 6. I need to equate this to g at x, which is 2x squared minus 2x minus 12. So now let's just work on this problem. Okay, so what I'm going to do is that I need to put this thing in standard form. So I can write this and say this is 2x squared minus 2x. The 2x will come to the other side to be negative 2x. Then we still have minus 12 plus 6. The 6 will come this other side to be positive. So remember, this is equated to 0 now. So let's add the like terms. This is 2x squared minus 4x plus negative, let's say this is minus 6. Minus 6, this is equal to 0. Can you see that we can divide everything by 2? I think you guys can agree with me when I say we can just divide everything here by 2, and this will be x squared minus 2x minus 3, it's equal to 0. Let's factorize. So when we factorize, this is x, then what are the factors of 3 is 3 and 1. Since it's negative, 1 should be positive, 1 should be negative. So we take the sign of the middle number, we give the bigger 1, and this one will be positive. So now, what is x? X is just 3, or x is just minus 1. So this was the first question. And we are done with the first question when they're asking where is f at x equals to g at x. These two graphs meet at x is equals to 3 and at x is equals to minus 1. Okay, let's follow the steps to graph these two graphs. So now let us plot the graphs. Let's plot the graph. Let's start with g at x. Okay, so now g at x, it's given as, I have g at x, which is 2x squared minus 2x minus 12. So this is 2x squared minus 2x minus 12. Right, remember the first thing that we do is to find the turning point. It's always important for you to start by finding the turning point first. Let's find the turning point. So if you still remember, on the other side, this one is in quadratic form. Hey, say, I can hear your voice, but the screen is paused. How is it now? Is it fine? Okay, 100%. So now, let me check also the YouTube team. Do you guys have any question? We can do one with P and Q as unknown. No, Ntombizoto, we can't do that, ne? We can't do that because if we do, still frozen. Guys, what's the issue today? Oh, okay, nice. So now when it's like this, you know what I'm going to do now? Let's plot the graph. First thing first, we need to find the turning point. So when it's like this, when you are given this equation and it is in quadratic form, to find the turning point, you have to first find the x value of your turning point. And the formula that we use, it's x, it's equals to minus b over 2a. And now remember, this is in the form of ax squared plus bx plus c. What is the value of b? Is just negative 2. So this will be negative inside the bracket negative 2. Everything is divided by 2 into 2. Therefore, the x coordinate is just 1 over 2. Right, so the x coordinate, it's 0.5. So now that you have the x coordinate of the turning point, how do we find the corresponding y value? How can we find the corresponding y value? So to find the corresponding y value, we have to substitute that 0.5 in the original equation. So I'm going to take this equation and find g at 0.5, or we can find g at half. So this will be 2 into 0.5 squared minus 2 into 0.5 minus 12. So just put that on the calculator and let's see what we get. What will be the corresponding y value? So g at 0.5 gives us 12 and half. So this is 12.5. So our TP, the coordinates of the turning point, it will be 0.5 and 12.5. So this is my turning point. So what's next? We have the turning point. What is the next step? Remember, when you plot the graph, you first start by finding what? You need to first start by finding Thank you, Ntombizoto, minus 12.5. So now we need to find the x and the y-intercept. Let's start with the y-intercept of that graph. Okay, remember, we have g at x, which is 2x squared minus 2x minus 12. So to find the y-intercept, we find the y-intercept if x is 0, meaning that on the equation where there's x, we need to put 0. So this is 0 squared minus 2 into 0 minus 12. So now, what is the y-intercept equals to? So this is just negative 12. So the coordinates of the y-intercept is 0 and minus 12. I hope everyone is happy on how we got that minus 12. Okay, so if this is minus 12, 12.5 is not negative. Oh yes, the 12.5 is negative. The 12.5 is negative. Let us fix that. The 12.5 is negative. User11, thank you very much. Jobs, welcome. Okay, so now we have that and we need to find the x-intercept. How do we find the x-intercept? Y must be equal to 0. So we just have to take y equated to 0 now. So we're going to say this is y. It's equals to 2x squared minus 2x squared minus 2x minus 12. So this is 2x squared minus 2x minus 12. Where this y we put 0. This is 2x squared minus 2x minus 12. I think everyone can agree with me that we can divide everything by 2. So when we divide everything by 2, what do we get? We get x squared minus x minus 6. Let me pause here and check if the YouTube has. Yes, guys, thank you very much. I saw that, ne? Thank you very much. So the 12.5 is negative. Thank you very much. Okay, so now when it's like this, we can factorize. I think it's going to be easy to factorize. We can open the brackets and let's equate this to 0. This will be my x. This will be my x. The factors of 6 that when we add or subtract, they give us the middle term of 1 is just 3 and 2. We take the sign of the middle number, we give it the bigger number, and this side will be positive. Therefore, x is 3, or the value of x is negative 2. So this tells us that the intercept is at 3 and 0, or it's at negative 2 and 0. So now that we have the x-intercept, what next? Because remember, we are plotting these two graphs. So we have everything for that quadratic function. Let us focus on the f at x. We are done with g at x. Let us work on f at x now. Okay, I'm just gonna take this step by step. So my g at x no, this is not g. Okay, this is not g. This is f at x. It's equals to 2x minus 6. So let's first find the y-intercept. How do we find that? By equating x to be 0. So this will give us y is equal to 2 into 0 minus 6. So the y is just negative 6. So if the y is negative 6, so the coordinates will be 0 and negative. I hope everyone is happy with that. Okay, So now we need to find the x-intercept, okay? So remember, we're going to use that and say we need to find the x-intercept. Y is 0, meaning that where there's y we put 0, and we'll have this as 2x minus 6. The 6 comes this side to be positive, and this will be 2x divided by 2 divided by 2. Therefore the value of x is 3. We have the value of x as 3. What's next? Since the value of x is 3, the coordinates of the x-intercept will be 3 and 0. Now we can plot the graphs. Let's plot the two graphs. Let's start with that quadratic one. Let's start with the quadratic. Okay, I'm just gonna take this step by step, but let me check if the YouTube team, you guys have questions. Tandeka, thank you very much. That's very correct, né? Thank you very much. Okay. Now, let's plot our graph. Okay, let's go back and refer what we have so far. Let's start with the quadratic one. So the quadratic one, we had the turning point as half and minus 12.5. Né? So that's my turning point. So I'm just gonna put it somewhere here because I know that half is here. So the 0.5 is somewhere there. So we go down all the way to negative 12.5. So this will be my turning point. So my turning point is there, and it will have the coordinate 0.5 is to negative 12.5. Right. So when it's like this, we need to plot the x-intercepts. So the x-intercept is 3 and 0 minus 2 and 0. 3 and 0, it's somewhere here. This will be 3 and 0. Minus 2, it's somewhere here. This will be minus 2 and 0. Then we need to plot the y-intercept for that quadratic. The y-intercept is 0 and minus 2. The y-intercept is 0 and minus 2. Let us quickly put that. So 0 and minus, what was that? It's 0 and minus 12. Let me just quickly confirm that. 0 and negative 12. So we know that negative 12 is somewhere here. Negative 12 is somewhere, so the y-intercept will be here. And the value of a was positive. This will be concave up, right? So the graph will be concave up. Okay? So this is my graph. I'm very sorry about the drawing. This is my graph of that g at x. Right, now that we have the graph of g at x, let us quickly plot the graph of f at x. We said the y-intercept, it cuts at 0 and minus 6. Let's go and put that 0 and minus 6 out. So I'm going to use a different mark. 0 and minus 6 is somewhere here. We know that this is minus 6. That's my y-intercept. X-intercept we just calculated to be 3 and 0. So 3 and 0 is somewhere here. So this is my 3 and 0. And now the value of a was positive. And now this tells you that your graph will look like this. So let's quickly put that. Nice. This is my f at x. So now that we've managed to draw the graph, let's answer the following questions. Okay, let's answer the following questions. For which values of x is g at x greater or equal to f at x? Where is g at x above f at x? Where is g at x above f at x? Let me quickly indicate that. Where is g at x? Look at this. The red graph is g at x. So where is g at x above? As you can see, from this point here, going up, that's my g at x, which is above f at x, and from this point here going up, that's my g at x, it's above f at x. So now this tells you that from this point going that side, f at x is above g at x, and from this point going in that direction, f at x is above g at x. I'm sorry, g at x is above f at x. So now to answer this, we're going to say that x must be greater or equal to 3, because it's from this point moving in that direction, and or x must be less than or equals to, we need that point of intersection, which is what we calculated at first. This is what we started by calculating. Remember, we calculated the point of intersection to be -1 and +3. -1 and +3. So I think this makes sense now. So x is equal to 3 and x is equal to -1. So already we know that this one is the point of intersection, and another point of intersection is at -1. So x must be less than -1. I hope everyone is happy with that. Now this makes sense. So this is how you answer the graph. Okay, let's keep on moving, guys. Let's keep on moving. Now let's work on another example. Let's work on another example. Right, on this example, we're going to find the equation of the graph. So let's say that in an exam, you are given an equation and they expect you to find, you are given the graph and they ask you to find the equation of that graph. So this is my graph, and let's say you are given the x-intercept. So this is -4, and let's say this guy here is 1. And they'll give you another point on the graph. Let's call this point 3 is to -21. Remember, this is not drawn to scale. Ne? Benzo, welcome. Thank you very much. Okay, so now let's say we need to find, the first question says find the equation of this f at x, in the form y is equals to a into x minus p squared plus q. So they want you to find this in the form of the turning point form. Right, let me check you guys on the YouTube part. Are you guys still with me? Are you still happy, guys? How is the network now? How is the network doing? The YouTube team, how is the network doing? I'm waiting for your comments. How is the network doing? You'll tell me, guys, how is the network doing? Okay, so now from this problem, let's answer this. They want us to find the equation. So remember, if we have the x-intercept, we have the x-intercept. So when you have the x-intercept, we're going to use the formula y is equals to a into x minus x1 into x minus x2. This is the formula that we're going to use. Now. And look at this. We know that x1 and x2 are your x-intercept. Okay, I see NJ. I'm not sure how to say your name. I'm just gonna call you 8544. I see you saying the network is fine. Okay, the YouTube part, everything is good. So let's substitute. So to work out this problem, first thing first, you need to substitute. So this will be y It's equals to a into x minus, inside the bracket we put minus 4. The other side will be x minus 1. Please make sure that if your x-intercept is negative, put it inside the bracket. OJ, thank you very much. Welcome. Okay, so now we can multiply out those negatives. Now we can multiply the negative and we can write this as y is equals to a into x plus 4 into x minus 1. Okay, so now what I need you to do is to substitute any point on the graph, and we only have one point, which is 3 and negative 21. So we need to substitute, we need to sub in the 3 and the negative 21. Soli, welcome. Okay, so where there's y, remember this is your x, this is your y. So where there's y, we need to put negative 21, which is equal to a into, where there's x, we need to put 3. So this will be 3 plus 4 into 3 minus 1. The aim is to find the value of a. Now, so 3 plus 4, this will be a into 3 plus 4, that's 7. And the other side is 2. And this is equated to negative 21. So now what is 7 times 2? It's 14. So this will give us 14a. It's equals to negative 21. Divide both sides by 14. Divide both sides by 14 to make a subject of the formula. What is a equals to? So 14 goes into 21 one time and it leaves a remainder. So this is negative 1.5. Right, so this is what we have. This is the value of a. Remember, we are trying to find the equation of the graph. So we need to take this value of a, substitute it on this equation. Please don't substitute on that one, please. So now we're going to say this is y is equal to, where there's a, we can put the minus 1.5 inside the bracket. We have x plus 4 into x minus 1. What's next? We need to multiply out the bracket with the negative 1.5. So this will be y. It's equals to, first thing first, let's do the FOIL method and multiply the two brackets. So this will be minus 1.5 into, this will be x squared minus x plus 4x, which will give us positive 3x, then minus 4, close the bracket. Now we multiply out of the bracket with what? We multiply out the bracket with negative 1.5. This will be minus 1.5 x squared, then minus 1.5 times 3 will give us a negative 4.5. So this will be negative 4.5x, and then we say minus 1.5 times minus 4, which gives us positive 6. So this is the equation of the graph in the quadratic form. So this equation, it is in quadratic form. But now remember that they said we need to put it in the turning point form. We need to put that guy in this form. We need to put it in the turning point form. So how are we going to do that? We need to complete the square. Let's complete the square. Let's take this graph and complete the square. So we need to complete the square. Remember, to move from quadratic to turning point form, you complete the square. So we have y, which is equal to negative 1.5x squared minus 4.5x plus 6. Let's complete the square now. So what I'm going to do to complete the square, first thing first, make sure that the value of a, you take it out as a negative. So what I'm trying to say is that when we take it out as a negative, is going to take us back to that form. We take it out and we can write this as y is equal to negative 1.5. I take it out as a negative and this will take me back to that form, which is x squared plus 3x minus 4, close the bracket. Now we can complete the square. Remember, when we complete the square, we add the, we're going to add, listen, when we complete the square, we add b over 2 squared, and then you subtract it. Right, let's quickly work on that. Let's add it and subtract it. So this will be y, it's equals to minus 1.5 into x squared plus 3x. Then after 3x, we're going to add that. What is the value of b? Is 3. So this will be 3 over 2, and this is squared. You add this, then you subtract it. So we're going to subtract the 3 over 2 squared, then we still have the minus 4. Right. So what I need you to do, I need you to punch. You can punch this guy. Okay, let's first look at this. The x squared and that. The first part of that equation, we're going to have what we call the difference of squares. So we can write this as y is equal to minus 1.5. Then into the bracket we have this as, you take the x here, x, then you take the what? You're going to take the 3 over 2, which is positive. We're going to add 3 over 2, then we write them inside one bracket, and this will be squared. Right, so now you just have to punch this guy here on the calculator. So minus 3 over 2 squared minus 4. When you put it on the calculator, we get negative 6.25. Then we close the bracket. Please don't forget to multiply out the bracket with that minus 1.5. You just have to multiply out the bracket with that. So y is equal to minus 1.5 into x plus 3 over 2 squared. Then we take this, multiplied with that gives us positive. So 1.5 multiplied by negative 6.5. So it's negative 1.5 times negative 6.5. This gives us positive 9.38. So we've managed to write this in the form of a into x plus p squared plus q. Is everybody happy with that? Do you guys understand what we did on this problem? Thank you very much. Thank you very much. Let's hear from the YouTube part. The YouTube team, are you guys happy? Do you guys understand what we did so far? I am waiting for your comments, guys. I know that the comments, they take time, né? Okay, now, okay, thank you very much. Okay, thank you. So you know now what we're going to do. We're going to work on some of the hyperbola questions. Né? We did parabola, we did quadratic equations. Now we're going to focus more on the hyperbola questions. Okay. Let's start with this one. Let's just draw the graph and then we can take it from there. Okay, I'm just gonna put my graph here. Okay, let's say that in an exam you are given the hyperbola graph. Okay, so the graph cuts at the origin like this. And then in this one it cuts like this. Okay, so let's put another graph there, which will be the straight line graph, which will cut at the origin also, and it's going to pass through somewhere there. Okay, I'm very sorry about the drawing. So this is my G graph and this will be my F. Okay, let's say that we have given a point here which is 3 and 3. Mpumelelo, thank you for the follow. We'll make sure that you feel at home. Thank you for joining the family. Hopefully you will feel at home. So this one, it's x, it's equals to negative 2. The asymptote, it's x, it's equals to negative 2. And then this one, it's y. So this one, it's y is equal to negative 3. Let's answer the following questions. Number 1. The first question we need to find, the equation of f at x and g at x. Let's find the equation of f at x and g at x. So this will be the last problem for the night. Né? So remember, the parabola, it is in the form of y is equals to a over x plus p plus q. So we just have to substitute this. Please pay attention on this one. Né? So this will be a over, this will be, we are looking for the equation of f, which is the hyperbola. So this one, we first have to check your asymptote. Your asymptote is x, it's equals to negative 2. So this will be x, it's negative 2. Let me write the equation correctly here. It's not x plus p. Most of the time we always use x minus p, so that when we substitute this, everything will make sense. So this is x minus 2 next. Oh no, this is x minus p. This is a sign that we need to rest now. So now, when it's like this, when we substitute, remember our asymptote is negative 2. Our vertical asymptote is negative 2. So this will be y is equals to x minus, inside the bracket, minus 2. The value of q is this y. So it's negative 3. You just have to put it as negative 3. Then when it's like this, you can work this thing out and say this is a over x plus 2. Then we still have that negative 3. Now the aim is to find the value of a. So ladies and gents, we need to find one point on that graph that we can substitute. We need to find only one point. Look at this. The graph passes at the origin. So the coordinates there is 0 and 0. Thank you, Soli. That's very correct. So the coordinate there is 0 and 0. This is my x, this is my y. So to find the value of a, I can substitute that. So I can say this is 0, it's equals to a over 0 plus 2 minus 3. The minus 3 comes on the other side to be positive 3, and this will be a over 2. Okay, I think now everything is easy. What will be the value of a? Because we just have to cross multiply. So we just have to say this is over 1. A is just 3 times 2, which is 6. The value of a is 6. So if the value of a is 6, what will be the equation of f at x? Thank you very much, user 116. So the equation of f at x will be equal to a, which is 6, over x plus 2 minus 3. Right, I hope you guys are happy with that. Let me check how you guys doing on YouTube. Okay, thank you. Alright, so now we have the equation of what? Now that we have the equation of f at x, we can find the equation of g at x. Look at this. G at x is a straight line. G at x is a straight line. So it's going to be g, it's in the form of y, it's equals to mx plus c. So if this is mx plus c, it passes through the points 3 and 3, so we can find, look at this. We already know that g at x, it cuts at 0. It cuts the y-intercept at 0. So since it cuts the y-intercept at 0, the value of c is equal to 0. So we can write this and say y is equals to m, y is equal to mx, because c is 0. So to find the gradient, I can just substitute that point where it passes. We can sub in the point 3 and 3. Remember, we have 1 point on the graph, which is this point here. We can substitute that point to find the gradient. Right, so this will be 3 is equals to m at 3. Even if you find the gradient, is fine. Even if you use the gradient formula, you're still going to get 1. So the gradient here is equals to 1. So because someone can prefer to use the gradient formula and say, you know what, I have this point which is 0 and 0, and I have that point which is 3 and 3. I'm going to use the gradient formula. If you do that, you'll still get it right. Right, so the gradient is 1. What will be the formula? So the formula is just y is equals to x. So this is the formula of what? G at x is just x. I hope this makes sense. Right. Okay, so now let's say that in an exam they ask you to find the line of symmetry. They really like to ask this question. Now, how can we find the equation of symmetry? So in most cases, let's first start by finding the equation of symmetry with a positive gradient. With a positive gradient. So, axis of symmetry that has a positive gradient. Right, remember the axis of symmetry with a positive gradient, y is equals to x plus c. You just have to find the value of c. The axis of symmetry always has the gradient of y, of 1. So we just have to find the value of c. And now we need to find one point there, and the axis of symmetry, we know that is the points that we're going to use is this point here, which is the point of intersection of our asymptote, which is x is minus 2 and y is minus 3. We need to substitute this point, which is minus 2 and minus 3. So that is the point that we need to use. So this will be we're going to sub minus 2 and minus 3. So where there's y, we put minus 3, it's equals to minus 2 plus c. Therefore, the minus 2 comes on the other side to be positive, and this will give us c to be negative 1. So the axis of symmetry with the positive gradient will be y is equals to x minus 1. So this is the positive gradient for the axis of symmetry. So we need to apply the same method. Karabo, thanks. We need to apply the same method to find for the negative gradient, because now in an exam we don't know if they will say positive gradient or negative gradient. So I just want you to know how to find for both. So if it's a negative gradient, we're going to have it as, so this will be y is equal to minus x plus c. So now we substitute the very same point. So we're going to sub that minus 2 and minus 3. So where there's y, I'm going to put minus 3, it's equals to minus into minus 2, then at c. So this is positive 2, it's minus 3, it's equals to 2 plus c. The 2 comes on the other side to be negative. Therefore, if it comes on the other side to be negative, c is just minus 5. So the equation with the negative gradient is just y is equals to negative x minus 5. This is the equation of symmetry with the negative gradient. Right, ladies and gents. So when you have it like this, please make sure that you attempt to practice all these questions. I will also send this on the group. Now, I'll also try to send this on the group. So now, and that's it for this lesson. This is where we're going to stop for today. I'm just going to wait and see if you guys have any questions based on what we've covered today. Do you guys have any questions? Let's see if you guys have any questions. If there's no question, then we can end the stream. Oh, user 119, it's you, Evelyn. Thank you very much. Thank you, sorry. Okay, no questions. This is where we're going to stop for today. Thank you guys for joining in. I'll see you guys on our next lesson. We're just gonna end the stream